All right. Looks like we're going to do Algebra 2, Lecture 929 and 930. OAS A2A14. The student will solve quadratic equations. Quadratic means that the highest power of our variable is going to be a 2. The equation means it's going to have an equal sign in it, and we're going to try to find values of the variable that will make these statements true. So we're going to solve quadratic equations by setting the equation equal to 0 if it isn't already set equal to 0. Then we're going to factor it using the T method because the leading coefficient won't factor out, and employing the zero product property. So that's what we're going to try to do. Let's see what it looks like. We've talked about the T method in the past, but we were just factoring. We weren't solving. Today we're going to be using the T method to factor and solve. So here we go. We're asked to solve this. That means find values of n that will make this equation true. The first thing we want to do is set this equation equal to 0. So I'm going to turn this into a 0 by adding 6 to both sides. The right side of the equation is now a 0. 7n squared plus 4n. And these are different signs, so I'm going to subtract. 9 minus 6 is 3. Keep the sign of the one with the greater absolute value is equal to 6 minus 6 is 0. Now I'm going to factor using the T method. I look and I see that I can't pull my leading coefficient is a 7, and these don't have factors of 7 that I can divide out, so I'm going to use the T method to factor this thing. Here we go. Put my T over here. I'm going to introduce an extra factor of 7. 7n times 7n is 49n squared, not 7n squared. So I've introduced an extra factor of 7 that I'm going to divide out here in just a second. By introducing this extra factor of 7, I can multiply these two together, a and c, if it were in general form, and get a 21. We can ignore the minus for now. All we want is factors of 21 now. We can look for factors of 21 that will add or subtract to give me a 4. Well, 21 and 1 won't work, but 7 and 3 will. 7 and 3 can be added or subtracted to give me a 4, so I'm going to put those in here, 7 and 3. And I want them to add up to or subtract to give me a positive 4, so my 7 has got to be positive and my 3 has got to be negative. So I've used the T method, I've introduced an extra factor of 7, and now I'm going to divide that extra factor of 7 that I introduced right back out. So I've multiplied it by 7, and then I'm dividing it by 7, so I'm not changing its value. It's just a tool to help us factor this a little more quickly. So this is the one that I can divide by 7. I can't divide this one by 7 because 3 won't divide evenly by 7. Both of these will. So I'm dividing both of these by the 7 that I introduced. 7n divided by 7 is n. 7 divided by 7 is 1. Oops. My board's having to think for a second. Okay. Now I've got it factored. I'm done factoring it, but our instructions are to solve. So what I want to do now is employ the zero product property, which says if you have a factor times another factor and it's equal to 0, the product is equal to 0, then one of these factors has to equal 0. So either n plus 1 is 0, or 7n minus 3 is 0. Both of these are pre-algebra problems. To solve this one, I simply subtract 1 from both sides, and I get n is equal to negative 1. That's one of my solutions if I haven't made any mistakes. This one, it's going to be a little like a 4-stepper. Some people will call them 2 steps, but I include, adding 3 to both sides is a step. Rewriting the equation is a step, so that's step 2. Dividing both sides by whatever the coefficient is here, in this case 7. And then rewriting the equation. N is equal to 3/7. So those are our two values that I can plug into this equation right here that will make this true. I can plug in a negative 1 here and here, do the arithmetic, and I'll get negative 6. Or I could plug in 3/7 here and here, do the arithmetic, and I'll get negative 6. So those are our two solutions, and they will usually, on the key, or in your multiple choice scenario, they'll be written in set notation, like this. The set whose members are -1 and 3/7. And the order of these elements of the set doesn't matter. It might be written like this. The set whose members are 3/7 and -1. Any of these three responses is correct. Don't make these parentheses. They're set notation. Okay? And let's see if I got it right. If I didn't get it right, I'm going to cry. 3/7 and -1. Yay! That calls for a sip of coffee. That's good. Okay, let's take a look at the next one. Move my little T thing up here. Okay, I'll look at this one and say, hey, this one's already set equal to 0. So I don't have to, up here I had to add 6 to both sides before I started. This one's already set equal to 0, so I can just start factoring. I'm going to try to factor 3 out of all of these, and I see that I can't, so I'm going to have to use the T method. So here we go. Using the T method, I'm going to introduce an extra factor of 3, 3p times 3p. Extra factor of 3, 3 times 3, 3p times 3p is 9p squared. I don't want that, so this extra factor of 3 that I've just introduced, I'm going to have to divide out here in just a second. But doing this enables me to multiply a times c, that's these two, you get 24 in this case, and I'm looking now for factors of 24 that add up to 14. Well, 1 times 24, 1 and 24 won't add or subtract, give me 14. 2 and 12, 2 times 12 is 24, and I can use those to add or subtract to give me 14, so yay. I want them to add together to give me positive 14, so they both have to be positive. So we've got it factored, but we have this extra 3 that we've introduced. 3p times 3p is 9p squared, so I'm going to divide it out of one of these, and this is the one of the binomial that will divide by 3 evenly. So I've introduced an extra factor of 3, and now I'm dividing it back out in my head. Dividing this by 3 gives me p. Dividing this by 3 gives me 4. 3p plus 2 is the other factor. This product is equal to 0, and now I'm in a position to use the zero product property, which says if you have two factors that are equal to 0, either the first factor is 0 or the second factor is 0. And now I'm going to solve these using pre-algebra. In this case, I'll subtract 4 from both sides and get p is equal to -4. That's one of my solutions if I haven't made any mistakes. In this case, I'm going to subtract 2 from both sides and then divide by 3. So I'm subtracting 2, rewriting my equation, dividing both sides by 3, rewriting my equation, and there's my answer, -2/3. And I can write my answer like this. Move this down just a little bit. Whoops, that didn't work. I can write my answer like this, or I can write it like that, or I can write it in set notation. The set whose members are -4 and -2/3. And the order of the elements doesn't matter. You can put the -2/3 first and the -4 second. This isn't an ordered pair. It's just the elements that are the set whose members are the values that will make this original equation true. I can plug in a -4 here and here, do this arithmetic, and I'll get 0. I can plug in a -2/3 here and here, do the arithmetic, and I'll get 0. Okay, and let's see if I got it right. Somewhere around here I have the key. Here it is. -2/3 and -4. Yay! Got that one. So there we are. That's how we do it. Let's see if I got one more. I do. Let's take a look at this one. We'll do the same thing. We're asked to solve this quadratic equation. We want to set, the first thing we want to do is set the equation equal to 0. So I'm going to subtract 2 from both sides. This will yield 5x squared plus 29x minus 6 is equal to 0. Negative 4 minus 2 is negative 6. Now I'm ready to factor, and I'm going to try, I see my leading coefficient is a 5, so I'm going to try to factor a 5 out of everything, and I quickly see that these won't divide by 5, so I'm going to jump into using the t method. See if it can be factored that way. There's my little t. I'm going to introduce an extra factor of 5, and then I'll divide that right back out here in just a second. So I'm multiplying by 5 and then dividing by 5. So essentially I'm not changing the value of anything. I'm just using a trick that will enable me to factor this thing. Now I'm going to multiply these two together. I'm not paying any attention to the plus or minuses, the negatives or positives. Just multiplying these two together and looking for factors of 30 that will add or subtract to give me 29. Well, the first one I try in my head is 30 times 1, and that'll work. 30 times 1 is 30, and 30 minus 1 is 29. So I'm going to put in a 30 and a 1, and I've got to add them together or subtract them, either way, but I've got to add them to get a positive 29. And the only way that can happen is if the 30 is positive and the 1 is negative. Now, I've got 5x times 5x is 25x squared. I don't want that, so I'm going to divide that extra 5x back out. And I can't divide these two by 5, but I can divide these two by 5. So in my head, I'm just dividing that 5 that I introduced right back out. Multiplied it by 5 and divided it by 5, leaving the value of x unchanged in the final analysis. So this will be x plus 6 times the quantity 5x minus 1 is equal to 0, and I set each factor equal to 0 using the zero product property and solve. If I set this equal to 0, I get x is equal to negative 6 by subtracting 6 from both sides. If I set this equal to 0, I get x is equal to 1/5. If I add 1 and then divide by 5, I'll wind up with x is equal to 1 over 5. And we can write our answer like this. It might show up like that in a multiple choice scenario, or it might show up like this. Or it might show up like this. Providing I haven't made any mistakes. I'll check here in just a second and see if I've gotten it right. Any one of these is an appropriate way to stick the solutions to this equation. That means I can plug in a negative 6 here and here, perform this arithmetic, and I'll get 2. Likewise, I can plug in 1/5 here and here, perform this arithmetic, and I'll get 2. And let's see if I got it right. 1/5 and negative 6. Yay! 1/5 and negative 6. So there we are. We just solved quadratic equations by setting the equation equal to 0. In one case, it was already set equal to 0. Factoring using the t method and employing the zero product property. You can do this.